So the mean value satisfies a wonderful mean value theorem for integrals. So this says if f is continuous on AB, then there is a number c which attains the average value. So f of c equals f of average, which is equal to 1 over b minus a integral ab f of x dx. So this can be visualized graphically very nicely, like down here. So you see the blue curve, and the area under the curve is the integral. And then the mean value or the average value is the red line, and there's one intersection right here. So the function on the value c is equal to the average value, equal to the red line. Here on the right is a different function, and this actually happens twice. So here the function is equal to its mean value, and here the function is equal to its mean value. So this point c is not unique. You can have many of those points, but they do exist. It's cool. And this has a wonderful interpretation. So look at the red formula again for the mean value theorem for integrals. Now if I multiply this by b minus a, then I get the blue formula here. But now this has a very specific meaning, right? If f is a positive function, then this here is the area under the curve. And the left-hand side has also an interpretation as area, right? It is a rectangle. So it's the area of a rectangle of height f of c. And f of c is the average. So we can find a rectangle which has the same area as the area under the curve. And this is again shown here. So the gray shaded region is the rectangle, the blue shaded region is the area under the curve, and these areas are exactly the same. Isn't that cool? Let's do that for the gene expression example. So for the gene expression curve, find a value c so that EC equals the average. So what we are looking for, you can see already in the graph, would be, for example, this point, where the function equals its mean value, and the mean value was equal to 1. So what we need to solve is 1 is equal to 1 plus 0.8 sine of pi divided by 150, and then the value c is the unknown value which I'm interested in. So for what value of c do I hit the mean value? And so the 1 cancels, the 0.8 is non-zero, so this basically means that the sine of pi divided by 150 c minus 120 has to be 0. And then this is satisfied if c is equal to 120, right? If c is 120, then inside the sign we have 0. So 120 is a point right here. So we found a value for c so that E of c, so then we get E of 120 equals E average, which was equal to 1. So we can do that. A mean value of a continuous function can be computed as an integral 1 over b minus a times integral a to b f of x dx. And the mean value theorem for integrals says that there's at least one number c so that f of c is equal to f average.